All right, get ready to dive into some pretty intense climate science today. We're going to be looking at the Antarctic ice sheet. And get this, projections show it could add a mind-blowing 4.4 meters to sea level rise by 2300.
That's right. It's enough to completely redraw coastlines and displace potentially millions, maybe even billions of people.
That's a pretty stark reminder that what we do today has a ripple effect for centuries to come.
Absolutely. The research we'll be looking at today is from the ISMI P6 Antarctica 2300 project, and it goes way beyond those typical 21st century projections we usually see.
Right, because they're actually looking ahead to 2300.
Exactly. They're using a mix of 16 different ice flow models and then also a selection of different climate model to really try to paint a better picture of what the future might hold for this huge ice sheet.
Okay, so 16 models. That sounds like a lot. Why so many?
Well, each model simulates the ice sheet's behavior and the climate in slightly different ways, and by combining all of them, we get a more well-rounded understanding of what the possibilities are.
So instead of just getting one expert opinion, we're getting a whole panel of perspectives.
Exactly.
So what's the consensus then? What do these models tell us about the future of the Antarctic ice sheet?
Well, the key takeaway is that under high-emission scenarios, we could be looking at up to 4.4 meters of sea level rise by the year 2300.
Wow.
And these high-emission scenarios represent a future where we don't really make any significant cuts to our greenhouse gas emissions.
Okay.
And while the ice sheet's contribution to sea level rise is going to be less than 30 centimeters by the year 2100, the rate of ice loss really starts to speed up after that.
So a slow burn that becomes a raging inferno.
Yeah, pretty much.
And I'm guessing this isn't happening the same way across the whole continent, right?
You're right, the Antarctic ice sheet isn't melting uniformly. The research actually points out some big regional differences. And one area in particular sticks out as being super vulnerable, the West Antarctic ice sheet.
Yeah, the infamous West Antarctic ice sheet. I've heard it called the weak underbelly of the continent when it comes to ice melt. So what makes it so much more vulnerable than other regions?
Well, unlike the East Antarctic ice sheet, which sits on bedrock that's above sea level, a lot of the West Antarctic ice sheet actually sits on bedrock that lies below sea level.
Okay.
So this makes it really susceptible to something called marine ice sheet instability.
Okay, so marine ice sheet instability. That sounds a little ominous.
Yeah.
What exactly does that mean?
So basically, warmer ocean water can kind of eat away at the underside of the ice sheet, causing it to thin and retreat really quickly.
Like a giant ice cube melting from the bottom up.
Exactly.
That's not a good visual.
No, it's not.
So this research is showing that this instability could lead to some pretty dramatic changes in West Antarctica, right?
Absolutely. Some simulations even show the potential for widespread retreat and near complete collapse of certain areas by 2300.
Wow.
We're talking about losing huge chunks of ice here, which would definitely contribute to that crazy sea level rise we were discussing earlier.
So this isn't just like a gradual melting. This is like large-scale collapse.
Yeah. Yeah, it's definitely a possibility.
So are there specific areas within West Antarctica that are really setting off alarm bells?
There are definitely a few key players to keep an eye on. Glaciers and ice shelves like Thwaites, Pine Island, and the Sipple Coast. They're all located in areas where the bedrock actually slopes downward as you move inland.
Okay.
And that kind of creates this slippery slope effect.
I see.
Once the ice starts retreating, it can be really tough to stop it. And then to make matters worse, all of these areas are exposed to these relatively warm ocean currents, which really speed up the melting from below.
So it just sounds like a recipe for disaster.
It's definitely a concern.
And I imagine that these glaciers are already showing signs of retreating, right?
They are. Thwaites Glacier, for example, has even been called the Doomsday Glacier because it's losing ice at such a scary rate. And the research gives us some pretty wild details about what this retreat might look like. For instance, the Bungenstock ice rise, which is another vulnerable area in West Antarctica, could see retreat rates of over 10 kilometers per year at some points.
10 kilometers per year. That's crazy.
It's fast.
So these glaciers are retreating, the ice sheet is thinning, and then we have the whole issue of ice shelves, right?
Exactly. Ice shelves act like these giant doorstops.
Okay.
They buttress the glaciers behind them and kind of slow down the flow of ice into the ocean.
Right.
But these shelves are also vulnerable to melting and collapse, especially as the world gets warmer.
Of course.
And when an ice shelf collapses, the glacier it was holding back can surge forward, adding even more to sea level rise.
It's like pulling the plug on a bathtub.
Yeah.
So I'm guessing this research also looked into what would happen if those ice shelves were to disappear.
They did. They actually ran some specific modeling experiments where they just took out the ice shelves completely,
Oh, wow.
just to see how that would affect the sea level rise projections.
And what did they find? Just how much worse could things get if the ice shelves go?
Well, the results are kind of scary. These simulations showed even higher potential sea level contributions, up to 6.9 meters by 2300.
Wow, almost 7 meters. That's really pushing the boundaries of what we even thought was possible.
Yeah, it's a lot.
But before we totally spiral into climate anxiety, let's talk about the uncertainty involved here. All these projections come with some degree of uncertainty.
Of course, it's really important to remember that.
Okay, so let's unpack that uncertainty. What are the biggest things that make it so hard to predict exactly how much the Antarctic ice sheet will contribute to sea level rise?
Well, the choice of ice flow model is still a big source of uncertainty, even when we're looking at these super long time scales. Each model has its own slightly different assumptions about how ice behaves, which can lead to a pretty wide range of outcomes.
So it's like trying to predict the future with 16 different crystal balls. Each one has its own quirks and biases. I imagine there are other factors at play as well, right? Not just the ice itself.
Absolutely. Things like differences in climate models, which try to project future greenhouse gas emissions and temperature changes, also add to the uncertainty.
So even if we had a perfect ice flow model, we'd still be dealing with the unknown of how much the planet will actually warm.
Exactly. And then there are other factors like bedrock uplift, which can actually slow down ice loss, and then the crazy interplay between all the different physical processes going on within the ice sheet, a lot of which we still don't fully understand.
So it's a complicated system with a lot of moving parts. Even with all these sophisticated models, there's still a lot we don't know for sure.
Definitely.
But that uncertainty shouldn't be an excuse to just do nothing.
That's for sure.
But if there's so much uncertainty, how do we even make sense of these projections? What can we actually take away from all this?
That's a great question, and that's what we'll get into next. The main thing to remember here is that the possibility of several meters of sea level rise in the next few centuries is a big deal that we just can't ignore. Even if we don't see those worst-case scenarios happen, even just 1 or 2 meters of sea level rise would have a huge impact.
So let's talk about that impact then. We're talking about possibly losing entire cities, right? What does that actually mean for people, for economies, and for global stability?
Exactly. It's a humanitarian crisis just waiting to happen, with potentially millions, even billions of people displaced. Just imagine what that would do to resources, infrastructure, social systems.
It's almost impossible to even imagine. And we're not just talking about losing land, are we? There are all these other ripple effects to think about.
You're right. Rising sea levels also bring things like increased coastal erosion, saltwater getting into freshwater sources, and then more frequent and severe flooding. All of those can be devastating for agriculture, they can disrupt our transportation systems, and damage crucial infrastructure like power plants and wastewater treatment facilities.
It's like a domino effect with some seriously bad consequences. And I imagine this would hit developing countries especially hard.
Absolutely. Many developing countries just don't have the resources to adapt to these changes, making them much more vulnerable to the social and economic impacts of sea level rise.
So we're talking about making existing inequalities worse and even possibly starting conflicts over dwindling resources. This is all sounding pretty grim. Is there anything we can do to lessen these risks? Is adaptation even possible on such a huge scale?
That's the big question, isn't it? It's definitely a huge task, but we've got to start somewhere.
Right.
Adapting to this is going to require a multifaceted approach. That means not just focusing on physical infrastructure, but also making social and economic adjustments.
Okay, so what would that look like, practically speaking? What kinds of adaptations are we talking about?
We'll need things like planned relocation, developing crops that can handle drought conditions, and really strengthening our disaster preparedness systems. Investing in early warning systems for coastal flooding and creating infrastructure that can withstand rising sea levels will be key as well.
It sounds like we need a complete societal overhaul just to begin tackling this.
It's definitely a massive undertaking, no doubt about it. And it's important to remember that adaptation alone won't solve the problem. Ultimately, the best way to really lower those long-term risks is to cut back on greenhouse gas emissions and limit the warming in the first place.
Easier said than done, I know. But this research really makes it clear that we're playing a dangerous game if we just keep going the way we are.
It's a big wake-up call, showing that what we do today is going to have consequences that last for centuries.
So we've established that the potential consequences are huge and far-reaching. But like we talked about earlier, there's still a lot of uncertainty in these projections. How do we actually make decisions and plan for the future when we don't know exactly how much sea level rise to expect?
Right.
Does all this uncertainty mean we could just throw up our hands and say, well, who knows what'll happen?
Not at all. Uncertainty shouldn't be a reason to do nothing.
Hmm.
In fact, it actually shows us just how much we need more research, better models, and a way of making policy that's based on caution.
So what do you mean by a precautionary approach?
It means that because the potential consequences are so severe and irreversible, we should err on the side of caution. Take steps to mitigate climate change, even if we aren't totally certain about exactly how much sea level rise we're facing in the future.
So basically, hope for the best, but prepare for the worst. And that preparation needs to happen globally, right? It's not something individual countries can just tackle on their own.
Exactly. This is a global issue that needs global cooperation. We need those international agreements to reduce greenhouse gas emissions. We need to share knowledge and technology to help developing countries adapt. And we need a collective commitment to building a more sustainable future for everyone.
That's a tall order, but it sounds like we don't really have another option. The stakes are just too high.
You're right. The future of our planet and the well-being of so many future generations depend on what we choose to do today.
That's a heavy thought.
Yeah.
But it's a conversation we absolutely need to be having. And speaking of conversations, this research gives us a lot to discuss. It gives us the knowledge we need to make smart decisions and really push for change. So for our listeners who might be feeling a bit overwhelmed by all of this, where do we even begin to make sense of it all? What can we actually do?
Yeah, it's definitely a lot to take in for sure, but the first step is just realizing that we're not totally powerless against this, right?
Right.
There are things we can do, both on our own and together, that can actually make a real difference.
Okay, so let's break that down then. What are some things that people can actually do?
Well, staying informed is always a good place to start. The more you understand the science and what's at stake, the better you'll be able to have those important conversations and really push for action.
Right.
There's tons of information out there on the ISIP6 project website, and there are lots of articles about Antarctic ice sheet melt and resources about how to deal with climate change.
Yeah, I totally agree. Knowledge is power, right? But aside from staying informed, what else can we do?
Don't underestimate the power of collective action, you know?
Yeah.
Supporting those organizations that are working to tackle climate change, voting for leaders who prioritize sustainability, even just talking to your friends and family about these issues, all of those things can create a ripple effect.
It's all about using your voice, your vote, your choices to try and make a more sustainable future. And I think it's important to remember that this isn't just about giving things up, right?
Yeah.
There are also new opportunities that come along with this.
Exactly. Moving to a low-carbon economy is going to create all sorts of new jobs, new technologies, new ways of living, and it's about changing how we think about our planet and building a future that's both sustainable and prosperous.
So it's a challenge, yeah, but it's also a chance for innovation and progress.
Exactly. This research really shows us the possible consequences of doing nothing, but it also emphasizes how urgent it is and how possible it is to create a different future.
Well, this has been a pretty deep dive, for sure. We've covered a lot of ground, from those mind-blowing projections of sea level rise to the complicated science behind ice sheet modeling and the urgent need for both individual and collective action.
It's definitely a lot to process, but I hope everyone listening comes away from this deep dive feeling more informed, more empowered, and maybe even a little bit inspired to be part of the solution.
Couldn't have said it better myself.
Mm.
And I think it's only right to end this with a thought-provoking question for our listeners to think about.
Okay.
We've talked a lot about how rising sea levels will affect us physically and economically, but what about the cultural impact? What happens to our history, our heritage, our sense of place when coastlines change and whole cities are lost to the sea?
Wow, that's a really profound question and one that deserves a lot of thought as we try to navigate the challenges and the opportunities of a changing world.
Well said. Thanks so much for joining us on this deep dive into the future of the Antarctic ice sheet. Until next time, keep exploring.